Hello everyone. Welcome to the session on OPC UA for Industrial Joining Technologies. I am Mohit Agarwal, System Architect at Atlas Copco Industrial Technique, Stockholm. Today we are going to discuss about what is VDMA IAS and what are the activities part of IAS. Then we are going to discuss background and the purpose of industrial joining technologies and what are the benefits for the end users and customers. Also, we will be covering upon on what is the scope defined for IJT tightening specifications and little bit details on assets and the results, and then what is the project plan and the current status. So let's quickly begin with the session now. VDMA Integrated Assembly Solutions. So what is VDMA IAS? It is a department in VDMA which represents the assembly and handling technology industries. Turbochargers to electric toothbrushes, many products consisting of many individual parts are assembled on complex machines. Hardly there is any other industry which brings lot of disciplines together, and this is something which really help in mastering the multitude of various technology and technical processes in the complex production environment. On the other screens, you will be able to see some example products of IAS, and also there will be a video which will showcase the application of IAS solutions in various manufacturing industries. So now let's move on to the next slide, which would be big picture of what IAS OPC UA initiative is. It includes two categories. One is end-of-arm tools, which helps in describing a variety of end effectors that are connected to a robot that can also be used as standalone application. So as part of end-of-arm tools, grippers is one of the systems which is being defined under that, and probably in future there will be more subcategories under end-of-arm tools. So there will be a specification, a standard specification defined for gripper systems from various vendors. Now coming to industrial joining technologies, which is the core scope of today's session, we are going to describe what IJT is. IJT was formed last year in May 2019, for the reason where a lot of customers and end users have a need to communicate between various systems based on a standard interface and also standard communication model. So Industrial Joining Technologies work group was formed, where we have defined a taxonomy, as we can see in the slide, and this taxonomy is in line with DIN standard 8580. So Industrial Joining Technologies has a subcategory called press together and press in, which includes tightening, flow drill fastening, join by press fit, etc. And also Industrial Joining Technologies has other mechanisms like gluing, riveting, clinching, filling, etc. So these are all the technologies which will be covered as part of IJT work groups. We will go through step by step in detail on how we are going to define the scope and what are the things which will be covered as part of IJT. So to start with, since there are many technologies under joining, we have to start with one specific technique. So we have started work on tightening specification, which will be the base or foundation block, which will be a foundation block to be reused by other joining techniques. And we are taking care of a lot of common features based on the technical discussion so that it is much more easier for other techniques to reuse the specification when they start the work on that. So this is currently in progress, and then there is a specification to define a standardized model for grippers that would probably have a draft version available by end of this year, and next year they will have a formal release. So this is about the overview on what OPC UA IAS initiative is. We are going to discuss about the purpose of industrial joining technologies. As we have explained in the previous slide, industrial joining technologies is a very important part of the assembly process, which includes various techniques like tightening, gluing, etc. Now the goal is to have a vendor independent and interoperable communication model between different techniques and between different vendors. And also there should be a common model for interoperability between other techniques. So with the help of first step, which is tightening, to define tightening related data, and also we are trying to define common features which will be useful or that can be reused by other joining techniques. So we have started the work for tightening for that reason. And other joining technologies like gluing, at least probably gluing would start in a month or so based on the current discussions, and other techniques also would follow. It's not like it's a waterfall model where everyone will start after the specification is released from tightening. It can be a parallel process. So there are discussions in progress, and once we have more updates, you will be knowing that from the VDMA portal. Next, we are going to discuss about what is the benefit of IJT specification. So as you can see here, without OPC UA IJT companion specification, there are different techniques, and different techniques communicate using their own vendor specific information models. So for an end customer, integration becomes a bigger problem. The bigger problem, and because there is no interoperability between different systems. This is the core problem or the need for starting the work group on IJT. Now let us go to a next slide where we will be able to visualize what will happen once we have the IJT companion specification. As we can see here, in the previous slide, we had multiple communication interfaces and multiple communication models. With the help of OPC UA IJT companion specification, which will be built on top of OPC UA core building blocks, that will help all the systems within the joining to communicate using one common meta. This is the end goal, which will really help the end customers for integrating different vendor systems into their production environments. Now let us go to the next slide where we are going to discuss about a brief overview on what is the scope of IJT tightening specification part 1. As we can see here, the end goal is to have an interoperable description useful for all the tightening systems within the tightening domain. And then this is based on OPC UA core object-oriented models. On top of the core models, and by reusing other companion specifications like OPC UA for devices, OPC UA for machinery, and define the building blocks, which will be reused by other joining techniques also. So initially, the first use cases which are considered as part of first specification is asset management, condition monitoring, results, and basic events. Let us describe these use cases to a more detailed view from in the next slide. As we can see here, asset management is one of the most important use cases with respect to defining other use cases. Asset management will help as a core building block and as a placeholder to define and integrate all other use cases of a system. So in asset management, with respect to end user will be able to get an overview and identification of physical assets in their system in a standardized way. In asset management, we are reusing OPC UA for machinery specification for identifying machine and relevant components in a standardized way. So for example, manufacturer, serial number, software revision, these are some standard parameters which are common for all the physical devices or physical assets within the given system. Then comes the most important use case for all the tightening related customers. What is tightening result? The tightening result is nothing but a process output of the tightening operation. And what would it include? It would include the measured torque, for example, the measured angle, and any variation in the measurements, any violation in the measurement based on the configuration, and any error information which will be part of the results. So this is the core thing which is needed by an end user to evaluate whether the tightening operation was successful or not, and details about what parameters are included within the tightening result. Then the next use case would be condition monitoring, which has close relation to asset management and also the error information inside the tightening results. So in the first part, we are going to define a minimal set of parameters which will be helpful to define or evaluate the health and the state of the physical asset and the system over a period of time. A simple example will be health status of a device, current temperature, or service related information of a tool, etc. Those are some basic examples for condition monitoring. Then comes basic events. This will be built on top of OPC UA core events model. And for part one, probably we will only define a placeholder which will be easy to extend in part two and later. Here we will define a basic building block for various set of events which can occur within the tightening. One simple example of an event is tool disconnected or tool overheated. These are some kind of events which can occur within a system. Okay, let's go to the next slide where we are going to discuss little deeper on asset management use case on what we have defined till now. So here we can see an overview of tightening system asset management. These are the list of assets which we have defined in the work group, and out of all these assets, controller and tool are the mandatory assets to model any specific system within tightening. The reason is, without that tool, we will not be able to perform any tightening operation. And controller, whether it is an independent physical controller or controller embedded on a tool, that is the place where OPC UA application will be deployed, and that will report the values or any other parameters to the external clients or MES applications. So that is the reason controller and tool are the minimal assets needed to define a specific tightening system. In the next slide, we will see an example view from an OPC UA client. As we can see here, the data which we have defined for asset management is very much flexible. We can define various types of tightening systems. For example, handheld tightening system, fixture tightening system, intelligent tool tightening system. Various type of models can be easily defined using the asset models created in the tightening specification. In this example, as we see here, we have handheld tightening system, and when we dig it deeper, we see a flat list of all assets, like flat list of accessories, batteries, cables, controllers, etc. That is one way of accessing the data of assets. User can get a flat list where he will be able to get all the information of a specific asset. Also, user will be able to see hierarchical and non-hierarchical relation between various assets. As we see here, we have a tightening controller and we have an identification module. This identification module is reused from OPC UA for machinery, where we have used the machine identification and component identification types. Then this tightening controller has a subcomponent called memory device, and then it is also connected to a stack light and a servo. And then the servo in turn is connected to a cable tool. So this is one way of visualizing the data in a hierarchical way, and one way of visualizing it is in a flat list. So this makes this model very flexible to define any type of tightening system. And we can see some relations here. The references is connects to. We are going to reuse the standard references which are defined in the base specifications like DI or machinery. Also, we are in discussion with OPC harmonization work group, where any specific reference needed for our group is going to be standardized, and we are going to use the most common and standard references needed to define relationship between various assets. So this was about a very quick overview on the tightening system asset management. In the next slide, we are going to discuss an overview on tightening result and the basic top level result. So let's go there now. As you can see here, we have a multi-layered approach to define result. As you can see, the top level result, this will be common for all joining technologies. When we say common, it will have a set of parameters and required references which can be reused by all joining technologies. For example, an identifier of the result, a high-level status of the result, whether it is successful or not, and the timestamp of the result, and so on. The end goal is to have a common result for all joining techniques, and in future, there will also be harmonization between other domains like machine vision, grippers, or any other systems where we can harmonize and use the most common result object. Then comes the tightening result. Now, similar to tightening, gluing can define the gluing result by extending the result, and similarly riveting result, etc. So we have included tightening result, which will have set of measurement values. It will also have results and also tightening traces relevant to the specific result. So this is something which we are going to cover as part of part 1. Then vendor specific extensions can be added by extending the tightening result. And in future, if we have more parameters or more features to be added to the tightening result, we can have future enhancements. So this way, the complete result object becomes much more flexible and extendable in future. So this helps us for future innovation, and there is no blockage to innovate at vendor specific level. So this is a very quick overview on results. So as there are 2 more use cases, condition monitoring and basic events. Those are something which would start soon, and the end goal is to finish them as soon as possible. Let's go to the next slide. Here are the members of IJT Tightening Initiative. You can see different vendors who are part of the working group. I represent Atlas Copco and have been part of this group from day one, and we are really having very good discussions, and we are having a very good progress, and we are near to the draft specification in a couple of months. So let's go to the next slide where we will see a high-level project plan. As I have told earlier, this work group was started in May 2019, and then we have completed first level of discussions on asset management and results. And we are going to start condition monitoring and basic events, which is something we are targeting to finish faster because we are only defining a basic infrastructure which will be useful and extendable in part 2 or later. So the end goal is to have a draft specification in Q1 of 2021, and then in parallel start the process for part 2 when the formal release process goes on. I mean, formal release process would take around 4 to 6 months. But in the meanwhile, we will start the technical work on part 2. So part 2 could include commands, control, job results, joints, locations, and more. This has not been finalized, but here you all can play a key role if you are from any specific manufacturer or if you are a vendor, and if there is any critical use case which is needed, which has to be part of the tightening specification part 2, please provide feedback. We will provide the different ways where you can help us provide feedback in the next slide. In this slide, as you can see, VDMA created a customer survey where user can answer very simple questions on some priority of the use cases and what is the use of OPC UA in their production systems. So it will be really helpful if you guys can participate in this customer survey and provide feedback. So these are some of the vendors, and the link for this slide will be provided after the webinar, and you all can provide feedback via this customer survey. This is the first option. The second option to contact us is to contact Etienne Axmann, who is the head of VDMA IAS. And you can also contact me. That's not at all a problem. You can contact any one of us in the working group and let us know if you have specific feedback and or specific inputs or priorities which are needed to be covered in part 2 or current review in the part 1, whatever we have defined. If you have any specific comments, you are most welcome, and that will really help in defining a very good standard specification. So that's it from my side. Thank you very much. Hope to hear from some of you soon. Have a nice day. Bye-bye.